Have you ever built an app and wondered, how can I pass tasks from one part of my system to another, even if they are running on different servers or at different times? Maybe you have one service that receives orders and another that processes them. And you want them to work independently without being directly connected. That's where AWS SQS comes in. It's a fully managed message queue that lets you send, store, and receive messages between different parts of your system safely and reliably, even if some parts are busy or offline. And today, I'm going to teach you, step by step, how to use SQS with Java, like we are in a classroom. Let's get started. Before we dive in, here's exactly what you'll learn in this video. First, we'll create a brand new Java project from scratch. No copy-paste, no setup shortcuts. Then, we'll connect that project to our AWS account using access key and secret key. No AWS CLI or complicated configuration needed. Once connected, we'll perform all the basic SQS operations one by one, such as create a new queue, send messages to the queue, receive messages from the queue, delete messages, and finally, delete the entire queue. We will learn each line of code, step by step, so that you understand exactly what's happening, even if you are new to AWS or Java SDKs. Open Spring Tool Suite. Go to File, New, Project, and select Maven Project. Provide a group ID, artifact ID. Leave the version as it is, packaging will be jar. Provide a name for the project and a description. Click Finish. The project is ready. Open pom.xml. Right now, it does not have any dependencies added. To interact with AWS SQS from Java application, we need AWS Software Development Kit, or SDK for SQS for Java. Open a browser and search for its dependency. Here, you will see two different dependencies, but we need to select the one having software.amazon package, since it is the latest. Click the latest version and copy for Maven. Paste it under Dependencies tag in pom.xml. As soon as you save, it will start downloading the jars for dependencies. Create a new class. Change the package. Provide a class name. Before we perform any operation on the queue, we first need to create an SQS client, which will interact with the SQS service. Define a variable of type SQS client at class level, since this client will be required in all queue operations across different methods of this class. Define a method that will initialize this client. Call static builder method of SQS client to start creating client. Now, in order to connect the client to a specific AWS account, we need to provide three things: the region where the client will connect and perform operations, access key, and secret key. To set the region, use its region method. Provide a region here, such as US East 1. And we must provide credentials with its credentials provider method. If you see here, it wants an object of AWS credentials provider. AWS credentials provider is an interface. And so, we will create an object of static credentials provider which implements it using its static create method. It requires an object of AWS credentials, which is also an interface. So, we need an object of AWS basic credentials, which implements it. We can create the object of AWS basic credentials with its static create method. AWS credentials consists of two parts: an access key, and a secret key, as you can see from the arguments also. Now, from where you will get these? Go to your AWS console. Click on the account name. Click on Security Credentials. Scroll down. Here you see access key. If you don't have them already, click on Create Access Key. This is warning since I am logged in with root user, and it should not be done. But for learning purpose, it's fine. Click on Continue checkbox and create access key. Here are the access key and secret access key. Remember to store them somewhere securely by downloading the CSV file, because you will not see the secret access key again if you navigate away from this page. Copy the access key and paste it in the code. Copy the secret access key and paste it in the code. Assign this to a variable of type AWS Basic Credentials. Pass this AWS Basic Credentials object to create method of static credentials provider. Assign this to a variable and supply this variable to credentials provider method. Finally, call build method to create SQS client and assign this to the class variable. Our SQS client is ready. Now, let's move on to the SQS operations using this client. The first operation would be creating a queue, since only then we can send or receive messages. So, define a method for creating the queue. To create a queue, we need to build a createQueue request using its static builder method, and we pass the name we want for our queue. Since the queue name will be required all time while creating it, sending, and receiving messages, so let us define a class variable to store the name of queue and initialize the name of queue. Pass this queue name here. Call build method to create the object of createQueue request. Assign this to a variable of type createQueue request. And call createQueue method on SQS client object, passing it the createQueue request. Now, let's test our createQueue implementation. Create a main method where we will create an object of this class and call initialize client method followed by createQueue. Run the program. This will take some time for creating AWS connection. It has completed successfully. Go to AWS console. Search for SQS. Here you see, the queue with the same name is created. If you look at its creation time, it's the same as the program. Click on the queue. This is the queue URL, which is used for sending and receiving messages. We will be getting this also through our program. Let's check if the queue has any messages. Click on Send and Receive Messages. Then click on Poll for Messages. This will check for messages in the queue. There are no messages at present. Let's write a message to the queue. But for this, we need to get the URL of the queue. So, define a method that finds and returns the queue URL. For getting the URL, there is a getQueueURLRequest class. Again, to create its object, call its builder method followed by queueName to provide the name of queue, and finally call build to create the object. Assign this to a variable. Call getQueueURL method on SQS client to get the queue URL, passing it the getQueueURLRequest object. This will return an object of getQueueURLResponse, whose queueURL method will give the URL of the specified queue. Return it from this method. Define a method to send message to the queue. First call getQueueURL method to get the queue URL. To send a message, use sendMessageRequest class. To create object of this class, call its builder method followed by queueURL and provide the URL of queue. Next, call its message body method with the message to send to the queue as argument. And finally, call build. Assign this to a variable of type sendMessageRequest. Call sendMessage method on SQS client, passing it the sendMessageRequest object. Remove this createQueue method call, since we have already created the queue, and call sendMessage method. Run the program. This will again take some time. Go to AWS console. Click poll for messages again. Look, we have received a message in the queue. Click on the message ID. This is the same message that we sent from the program. If you look at the message sent time, it is the same as when the program was run. Let's run the program again. Back to AWS console. Click on poll for messages. We have another message. If you see the receive count, it has increased to 2. Now, let's fetch the message we just sent. To do this, we will use the receive message request. Define a new method to receive message. Creating receive message request object is the same as we did for others, using its builder method followed by setting the queue URL. Here, we will directly call getQueueURL method. We can set the maximum number of messages that we need to receive with max number of messages method and passing it the number. If we do not use it, then it will fetch all the messages. Finally, call build and assign it to a variable of type receiveMessageRequest. Now, use SQS client to receive messages with its receiveMessage method, passing it receiveMessageRequest object. ReceiveMessage method returns a list of messages from the queue. We loop through this list and print the body of each message with its body method. This is where we get the actual content of the message that was sent earlier. Call receiveMessage method instead of sendMessage. Run the program. This will take some time to receive message. We got the message. If you see here, we received only one message, while we sent 2 messages. This might happen sometimes, and to avoid that, you can add some delay with waitTime seconds method. Once we process the message, we need to delete it so that it doesn't get picked up again. This ensures that we don't process the same message more than once. Let's create a method to delete a message. A message has a receipt handle which acts as a reference to the message. This is a string, and we get this handle using receipt handle method of this message object. So, in order to delete a message, we need to call delete message method from here only. Delete message method should now accept a string argument. Now, if you have watched the video carefully and completely, you can easily write the code to delete a message. Pause the video and try writing it for yourself. Okay, now let's look at deleting a message. Create an object of deleteMessageRequest with its builder method followed by queueURL method, then setting the receipt handle of the message, and finally, build. Call deleteMessage method on SQS client, passing it the deleteMessageRequest object. Let's send a message first. Go to AWS console. Poll for messages. We have one message. Now, let's call receiveMessage, which will read the message and also calls deleteMessage internally. Successful. Back to AWS console. Refresh. Look, the message is deleted. Finally, after we are done working with the queue, we should delete it to clean up our resources. Create a new method, delete queue. Define a delete queue request using its builder method and then passing the queue URL to be deleted and build. Call delete queue method on SQS client. Run the program. Back to AWS console. Go to all queues. The queue is deleted. So today, you learned how to create a queue, send messages, receive and process them, delete messages, and clean up your queue when done. Now, you can build systems where different parts talk to each other smoothly without being tightly connected. And because SQS is managed by AWS, it works even if your app scales to thousands of requests. In future videos, we can go deeper, like handling delays, retries, or even connecting SQS with other AWS services. If this video was useful, make sure to subscribe so you don't miss upcoming videos.